Good morning, Namaskar. I welcome to all senior officers and participants who have joined on this webinar series on dam safety at space. This is a very important topic of this webinar series. Till date, we have conducted three webinar sessions on dam safety aspects. Now the participants are joined. We will wait for 5 minutes and then we'll start our today's session. Today's session is fourth session on this webinar series. The topic of this today's webinar session is review of hydrological safety of dams. Dear friends, National Water Academy has taken a very important role in capacity building in dam safety aspects because this is very important topic. Recently, Government of India enacted Dam Safety Bill Act 2021 and then and also Government of India taking lead to set up National Dam Safety Authority for dealing with this very important topic of dam safety aspects in India. National Water Academy plan a very long webinar series on this very important topic. National Water Academy Pune conducted about three sessions till date on this webinar session. First session was conducted by National Water Academy on dam safety aspects, and NWA has get very huge response. About 698 participants across the country had joined the first webinar session on Dam Safety Act. Then second topic was conducted by National Water Academy on Dharma software. This is also very important topic. About 685 participants across the country has participated in this second webinar session on of this webinar series on dam safety aspects. Last week we have conducted a webinar session on dam inspection, and about 530 officers at senior, junior and all level across the country had joined this webinar series. NWA has gets very huge response, and now today's session is on review of hydrological aspects of dam. This is very important topic because all related to dam safety aspect. Hydrology is a very important topic, and to get the review of hydrological safety of dams, how hydrology as well as hydrological parameters and hydrological parameters that is design flood, then design discharge, sedimentation, how these are very important for the all level of the water resources project, that is at planning stage, at design stage, at construction stage, and after the maintenance stage. Because maintenance stage at maintenance stage, hydrological safety of dam is very important parameter to guide us on or to share on this very important topic. Today with us available and very renowned faculty. Before start the session, I will first briefly introduce to our today's speaker. Uh, Today with us available to speak on this very important topic or share on his experience. Today with us available Shri Nityanand Rai. He is a graduate in civil engineering. He obtained his master in hydrology from IIT Roorkee. He is a recipient of Merit Award of Central Water Commission and Vice Chancellor Gold Medal of our university. He has over 26 years of experience with Central Water Commission and currently work and he is currently working as a chief engineer in MTBO Central Water Commission Gandhinagar. He, Gandhinagar, Shri Rai has carried out hydrological and hydrodynamic modeling for more than 300 river valley projects across the country for water availability study, design flood estimation, then dam break analysis, then glacier lake outburst flood studies, backwater studies, reservoir sedimentation profile studies, surge analysis, reservoir and channel routing studies. Uh, Rai sir has carried out hydrological and hydrodynamic modeling for more than 300 river valley projects. He is having a very huge experience on this very important topic. He has been using appropriate technique and model such as HEC HMS, then HEC Geo HMS, then ArcGIS, ILWIS, HEC RAS, then HEC GeoRAS, then HEC RAS2D and Mike 11 software. He is also a very professional and he has having good, very rich experience in hydraulic modeling applications or IT tools. He is one of the very few experts who have evolved the methodology for glacial lake outburst, flood estimation, and carried out number of studies, including a very detailed analysis of Uttarakhand flood of June 2013, then Jammu and Kashmir flood of September 2014, then flood storage estimate of Ganga and Brahmaputra, which are one of the very largest basin in the country. He made significant contribution in environmental flow estimation for proposed river valley projects in Siang, Subansiri, and Himalayan Ganga subbasins using hydraulic rating cum habitat simulation techniques. He has delivered a number of lectures, sessions on hydrological, hydrodynamic, and environment flow modeling for Central Water Commission, then IIT Roorkee, NIH, and NHPC, then CBIP, NTPC, and Water Resources Department of State Government. And he is the regular faculty on this very important topic at National Water Academy, CWC Pune. He has authored more than 34 technical papers in field of hydrological and hydrodynamic studies, environmental flow estimation at various journals in national and international conferences. Today with us and very renowned expert faculty on hydrology aspect to share his experience. Now I hand over the session to our today's eminent speaker, eminent faculty, Shri Nityanand Rai sir, and will with request, sir, kindly share your experience and guide to our participants on this important topic. Rai sir, please.
Thank you, Milinji. I am just sharing my PPT.
Yes, sir.
I think it is visible to everybody.
Yes, sir.
Okay, so good morning, friends. So, because in dam safety, the design flood aspect is very important. Because most of the dams which are already existing, they have been designed or its hydrological parameters were estimated something around 50 years before or 40 years before or 30 years before. And whenever we are going for dam safety review of any dam, so our first and foremost requirement is to check whether its design flood uh, has been reviewed or not, and if it has been reviewed, when it was reviewed, and what is the spillway capacity, whether the present design flood uh, shall be able to be handled properly with the existing spillway capacity. So this is a very important aspect of the dam safety in India. So in this basically topic, I will cover uh, how we are estimating the design flood for existing projects if catchment area is not too large, and if the catchment area is very large, because in some of the projects your catchment area may be 20,000, somewhere it may be 50,000, somewhere it may be 3 lakh square kilometer. In that case, all these design floods are being estimated.
సార్ లాంటిది చేయించాలి.
Well, it is not changing.
सुप्रिया को बुलाना, फोन करो जल्दी। सर स्लाइड चेंज नहीं हो रहा है। Yes, sir. Now slide has been changed.
Yeah. Now, am I audible to everybody?
Yes, sir. Yes, sir. You are
Yes,
audible.
audible.
Yes,
Yeah.
sir. You are audible.
Okay, okay. So, this design flood study, what is this? A flood hydrograph or instantaneous peak discharge adapted to design a river control structure after accounting for hydrological and economic factor is called the design flood. So, like instantaneous peak discharge, so that is also important. Like whenever we are designing the barrages, weirs, etc., then perhaps we are least bothered about the entire flood hydrograph. There, we estimate the design flood based using the frequency analysis. We may, like for barrages, we are nowadays we are waterways. We are providing for 100-year return period flood, and then HFL we are computing for 500-year return period flood or standard projection flood. But in the case of dams, apart from the peak discharge, flood hydrograph is also important. So there generally we are using hydrometeorological approach to estimate the design flood, where it may be the 100-year flood or standard project flood or probable maximum flood. And as per BIS criteria, seeing the hydronic head and the volume, gross volume, the gross storage of the reservoir, we are adopting appropriate design flood. So, what are the important aspect about the design flood? This design flood corresponds to the maximum tolerable risk. Another important aspect here is project can sustain without substantial damage to its component as well as people and property. So it means certain damage can be allowed, like in the Stilling Basin, if that design flood is coming and water is getting discharged through spillway, flood peak is getting discharged, so certain damage is acceptable. Whether design flood, whatever we have estimated, can be exceeded? Yes, certainly it can exceed, because the design flood we are estimating, or we have estimated considering the past events, considering the even isohydral pattern of the past events, and those events can exceed in the future. So possibility of exceeding the design flood is there. The risk of damage is equivalent to probability of occurrence of flood larger than the design flood. So these are the important aspects when we are going for the design flood computations. This we have to keep in mind. Why this problem is coming?
मुझे तो क्लिक करना होगा। अगर आप वेट पे जाएंगे तो फिर हाँ।
Okay. Okay. So what is the purpose of the design flood? Purpose of the design flood is for the safety of them, for designing the energy dissipation system, and to also sometimes we would like to know extent of upstream submergence, then downstream damages. So normally suppose a project is getting or being designed for a probable maximum flood, then the upstream submergence shall not be estimated uh, for the probable maximum flood. It will be depending upon the type of settlement of stream. There is the criteria we can adopt for 25-year flood or 50-year flood to see the upstream submergence in the form of backwater. Then downstream damages, like if in the downstream some powerhouse is there, then it's at what level, its formation level to decide the formation level. Again, perhaps we have to consider the probable maximum flood. So these are the uh, purpose of design flood estimation. Proper selection of design flood is very important, because here you have to think, if we are going to have a very high design flood, then you have to put additional costs for making the spillways. Then again we have to see the additional cost of structure versus risk of losses to structures and affected people and property. So some we have to think like that. Now let us come to the point whether absolute protection is possible. Perhaps that is not possible. That is, if you are thinking like that, that is unrealistic thinking. Increased risk, that is also not acceptable. So decisions has to be taken somewhere in between. Now BIS code has given some criteria, and using those criteria, like in India we are following IS 112223 1985 for selection of design flood of dam, and as per this criteria, if the gross storage is between 0.5 MCM to 10 MCM, means million cubic meter, and hydraulic head is 7.5 to 12 meter, then the structure shall be designed for the 100-year flood. If the gross head is between 10 to 60 MCM and the hydraulic head is between 12 to 30 meter, then the structure shall be designed for the standard project flood. If gross storage is greater than 60 MCM and hydraulic head is greater than 30, then the structure shall be designed for the probable maximum flood. Now, again here, suppose one structure is like that, its hydraulic head is 28 meter, but the gross storage is 80 MCM or 65 MCM. Then again, if any of these criteria is meeting, then the design flood shall be selected according to this given criteria of the BIS code. So if your grass head is 28 meter, but the grass storage is more than 60 MCM, then again you have to adopt only probable maximum flood, or vice versa also. Suppose your hydraulic head is 40 meter and my grass storage is only 40 MCM, then again I have to go for the probable maximum flood. So like that, if either hydraulic head or grass storage, any one of the criteria is meeting, then you have to adopt the design flood as per this BIS criteria. Then there is another code, that is IS 6966 part 1 for selection of design flood for barrages. So for assessment of freeboard, a 500-year return period flood or SPS, whichever is higher, that shall be adopted. For waterway, Generally, BIS code is telling 50-year return period flood, but nowadays most of the designers are adopting a 100-year return period flood for the waterway design. Again, for diversion during the construction period, this BIS code is IS 100 at 4 Part 1 1982, which specifies 25 to 100-year return period flood depending upon the temporary season nature or more than one season nature of the diversion work. If your main dam is like earthen dam, then we have to go for the 100-year return period flood. But in the case of concrete dams, we can go for river diversion work. We can go for 25-year return period flood, and that 25-year return period flood shall be adopted generally for the construction season or non-monsoon period. After this, now this Dam Safety Act has come in India. Now, as per this Dam Safety Act, the design flood review referred to in clause B of subsection 2 of section 38 of the Dam Safety Act shall be carried out every 10 years. Means for existing dams, we have to go for the design flood review at every 10 years or such lesser period as may be determined by National Dam Safety Authority. Of suppose some dam, its design flood was reviewed 5 years before, but its design flood has exceeded this year, then Dam Safety Authority may recommend that now you go for it's again once you have to go for the design flood review. So minimum 10 years are as decided by depending upon the occurrence of the flood. Uh, National Dam Safety Authority may direct for the design flood review. What are the different approaches for design flood estimation? If you see earlier, there were very limited data. So formula approach was adopted, like we must have seen Dickens formula, Ravi's formula, Nawab Jung Bahadur, different type of formulas are there. But those formulas are based on basically catchment area and very few observations are available. So those were very uh, initial approaches where very limited data was available and some rough estimate we are getting. So that was the formula approach. Then came the statistical approach, commonly known as flood frequency approach. This is a very good approach if you are having a long-term data, this gauge and discharge data. It is available for even more than 20 years or 30 years. Then this approach can be adopted for the design flood estimate. So normally, what we prefer, suppose if the data length is 30 years, then you can estimate flood of 100-year return period flood, 200-year, but we cannot use this 30 years data or 40 years data to estimate the probable maximum flood because its return period may be one in 10,000 year or more. So that is the thing. So normally return period flood 25-year, 50-year, 5-year, 100-year, all these return period flood can be used using flood frequency approach. But the problem with flood frequency approach that you are not going to get the flood hydrograph. So the volume associated with that particular flood event, you are not able be able to capture. That is the one of the limitation of the statistical approach. The hydrometeorological approach, which commonly known as unit hydrograph approach. So in unit hydrograph approach, we can get the complete flood hydrograph and what is the volume associated with that also be known to you. So that can be used effectively even for the inflow forecast and even for pre-depletion of the reservoir, for flood mitigation or reservoir operation. So because here the important this flood volume plays a very important role in reservoir regulation and operation of the gates during the high flood. Now, depending upon the catchment size, in the flood design flood can be estimated using hydrometeorological approach, either adopting a lumped model where a single catchment will be used or quasi-distributed model where you have to consider a number of sub-catchments of your project catchment if its catchment area is too large. So, in design flood computation, using hydrometeorological approach, I will discuss here the hydrometeorological approach because flood frequency approach most of the people are knowing. For that, if your flood peak data is there, then using your Gumbel distribution or log normal distribution, log Pearson type 3 distribution, you can estimate the appropriate uh, return period flood. And then there are tests like chi-square test, t-index test to know which is the best fitting distribution for your given data set. So using that, you can go for the flood frequency analysis to estimate the particular return period flood. But in hydrometeorological approach, because here we are computing the entire flood hydrograph. So this approach involves estimation of the design storm hydrograph or effective rainfall hydrograph. Normally we call it ERH. Then derivation of the direct runoff hydrograph from the catchment response function unit hydrograph. So in this design flood computation involves modeling of the process of transformation of rainfall into flood hydrograph and translation of that hydrograph through the water set up to the outlet point. So whenever you are going for the design flood computation using hydrometeorological approach, so what I have written here, so what data, basically input data shall be required. First, you should have this salient feature of the project. Then you must have a design storm depth and you must have a unit hydrograph for the project catchment. So these are our basic requirements. From where you can get the design storm depth, because this is the most important part of the design flood estimation. So Central Water Commission in association with the IMD has published a number of PMP atlas. These PMP atlas, entire country has been covered. So Central Water Commission has published this PMP atlas of Ganga Basin, Godavari Basin, Krishna Basin. This has been prepared by IMD in year 2018. Then this is the IMD publication, but Ganga, Godavari, this is the has been published by Central Water Commission. Then Narmada, Tapi, Sabarmati, and Luni river system, and rivers of Saurashtra and Kutch regions, including Mahi. This has been published by Central Water Commission. Then Mahanadi and adjoining river basins. This has been published by Central Water Commission. West flowing rivers of Western Ghats, Kerala. This has been published by Central Water Commission. Kaveri and other is flowing rivers. This has been also published by Central Water Commission. So only Krishna Basin and another Indus Basin. This has been published by IMD. So in these, this is a very wonderful document because a lot of effort has been made around. This is a joint effort of a number of experts sitting together, and it took around 3 to 4 years to they have prepared this document. A lot of data from including Bhutan and Nepal. This rainfall data from those countries were also collected, and whatever the data bank is available with the IMD regarding the past rainfalls. Whenever suppose in year 2010 this process was started, so up to year 2008 or 9 all the data was taken, and using that data this very detailed analysis was carried out to estimate the grid-wide PMP values, SPS value, moisture maximization factor, this different type of adjustment factors like location adjustment factor, barrier adjustment factor, a lot of things, because in the whenever you are going for the design storm depth computations, so a lot of things, a lot of meteorological parameters you have to compute, and all those computations have been made. You can directly read the value of your standard project storm or probable maximum precipitation using these PMP atlases. What are the beauty of these PMP atlases? If you see, so here 1 day, 2 day, 3 days severe most storm occur And this inventory is available, iso height of those storms and what was its aerial extent. So all those things, what was the, where was its I location? I location means I that location where the maximum depth has been recorded. Like what you are seeing, this is a 2-day storm in Ganga Basin, which occurred during 10 to and 11 July 2004. This is a 2-day storm. So this 2-day storm isohydral pattern you are seeing here. Same way you will get the 1-day storm, 3-day storm, and number of whatever the supposed threshold limit. When I was also a member of that committee, just to guide the publication of this PMP atlases. So in that first one threshold value was taken. Suppose for Ganga Basin we have considered 1-day threshold value of say 250 millimeter or 300 millimeter. So once this threshold value is decided, then all the storms which are having the 1-day recorded depth of more than 300 millimeter, all those were selected. Then what was the depth corresponding to second day, corresponding to third day, to base using all those calculations, 1-day, 2-day, and 3-day storms first were selected, and then their detailed isoids were also prepared. So, and this is very useful because making one isohide itself takes a lot of time if it is readily available, and these are the historical records because in 2004, same way in 2008, in 1938 some storm occurred. So from 1906 onward, this isohydral patterns of the severe most storms are available in the PMP Atlas, and these PMP Atlases are freely available. You can download these PMP Atlas on PDF format from our Central Water Commission website. And in these grid point location, like see, Ganga is a very big basin having the catchment area of about 10 lakh square kilometer. So at every 1 degree, one by 1 degree grid, you will see these grid point locations has been marked, and once you have mapped your catchment area, then you corresponding to the centroid of the catchment, what is the latitude, longitude, you can note it down. And once you are having the latitude, longitude, then using this figure, you can be easily able to see, you will be easily able to see or finalize which is the grid location or which grid location should be considered for my PMP or SPS value. So this is the map for that. Here you are seeing this latitude and longitudes are given. So once you have got the latitude, longitude of the centroid of your catchment, then you can decide the grid. Once you have decided the grid, then these are the PMP values. This is for 1-day aerial PMP estimate for 500 square kilometers. Same way you can get for 100 square kilometer, 500 square kilometer, 1000 square kilometer, like that. PMP values are given. These are the aerial PMP values. So everything is readily available to you. From here, you can get the design storm depth values. So PMP, SPS both. Now in the tabular form also, once you have finalized your grid location, like G and G means Ganga, and grid name it 4092. So using this map, now you can, based on your latitude, longitude of this entire of your catchment, you shall be able to know what is your grid location, and then using this table. Now depending on the catchment area, suppose catchment area is 800 square kilometer, then you are for 800 square kilometer, you are working out the SPS value. So here for 500 square kilometer, if you see SPS value is 688, for 1000 square kilometer, this is 664. So what will be for 800 square kilometer, that you can interpolate. So 1-day, 2-day, because depending upon the time base of the unit hydrograph, you have to select whether you have to go for the 1-day storm depth or 2-day. If your time base of the unit hydrograph is between say 28 to 48 hours, then you have to go for the 2-day storm depth. So here 2 day storm that depth is also, so what you are seeing like 1 day storm that corresponding to 31st August 1915, then 2 day storm that 1st August and 1st September 1915. So 1 day and 2 days, every value you can get from these tables, and from these tables aerial value corresponding to area. If your area is not given here, your area is lying in between, then you can interpolate it. Now, next comes, well, you have got the, now I've told you how can you get the design storm depth values. Now, next, suppose your project is qualifying for 100-year return period flood. Then in that case, IMD has published the isopluvial map. Using those isopluvial map, you can take the value of 24-hour rainfall depth of different return period, 50-year, 100-year, whatever the return period is required. And using that, suppose you want to estimate the 100-year return period flood, then you have to take the 100-year return period and fall value from the isopluvial map published by IMD. In our PMP Atlas, also the 100-year, 1 day and 2 day depth are given station-wise. But in the isopluvial map, the beauty is an isopluvial map. There, based on the latitude, longitude of the centroid of your catchment, you can easily read what will be my 100-year return period rainfall value at this location. Now, next comes the unit hydrograph. So, the catchment response function used can be either a lumped system model or a distributed system model. So, in the lumped system model, I have already explained, here the unit hydrograph is assumed to represent the entire catchment area. But in distributed model, the catchment is divided into smaller sub-regions, and unit hydrograph for each sub-catchment is worked out. And then for all these, because each sub-catchment is going to behave as a lumped model, and from one lumped model, from the outlet of one sub-catchment to another sub-catchment, the flood is to go by channel routing. It will subjected to the process of channel routing. So there we have to, whenever we are going for the such type of distributed or quasi-distributed model, then this model setup will consist of lumped component and reservoir routing and channel routing component. So to account for translation and attenuation of the flood peak also. So lumped model do not account explicitly for the spatial variability of hydrological process, whereas the distributed model do. So lumped model use average to represent the spatially distributed function and property. So, but if the catchment area is small, say 2000 square kilometer, 3000, your lumped model is more than sufficient. But if your catchment is 20,000 square kilometer, then your lumped model is not going to work. You have to go for the quasi-distributed model or distributed model. So this is the example what I was telling you, like this is a lumped model, like a dam is here, its dam location is here, this is its catchment area. So here single catchment, this is a lump. But what you are seeing, this is for Kadana Dam of Gujarat. So we are here, you are seeing the total 7 sub-catchment has been made. So like consider this sub-catchment. So how this is going to work? How you are going to set up a model for this? So what you have to do when you are going like that? So in that case, you see for each sub-catchment, one outlet is there. So like take SB2. So here the lumped response is getting received, means its flood hydrograph you will get at its outlet, and from this outlet up to this dam side, this flood hydrograph what you have got at junction 2, this will get channel routed through reach R2K, and it will come at Kadana Dam side, and at Kadana Dam side this response, lumped response of SB1, this is the SB1. So SB1 will also come, and this entire system response up through lumped and channel routing, it is coming to junction 5, and from junction 5, this will again channel route and it will come here Kadana Dam. So at Kadana Dam, what you are seeing here, in this, there are, you see 3 dotted lines. So 3 response. One is the response lumped response, another is the channel routed response through R2K, and another is channel routed response through R1K, and then the thing will be combined together, so that you will give you that you will get the flood hydrograph at this dam location. Like that, this distributed quasi-distributed model works. Now, what is the unit hydrograph? This is the response of the any catchment for 1 centimeter of excess precipitation. It may be 1 centimeter means 1 unit of excess precipitation in India. Like in our flood estimation reports, we are using 1 centimeter depth. But if you are using HEC HMS, then there it is corresponding to 1 millimeter, because there in HEC HMS everything unit is in millimeters. So their rainfall also you have to give in millimeter, and unit hydrograph values also should correspond to 1 millimeter of the rainfall excess, or 1 inch. So like that, 1 unit, the unit may be millimeter, centimeter, or inch. If your unit hydrograph ordinates are corresponding to 1 millimeter, then the rainfall also you have to take in millimeter. That unit conformity you have to ensure it should conform with the unit hydrograph rainfall excess. So the theory behind that is key, this 1 unit of rainfall excess which occurred, that is spread uniformly over space, evenly over the watershed. Uniform in type, the excess rate is constant over the time. Means suppose in 1 minute I am distributing in 15 seconds or 10 seconds. So we are assuming that at every 10 seconds the rainfall intensity was same. And there is a given duration, like what we read, 1 centimeter, sometimes this is the unit hydrograph of 1 centimeter rainfall excess in 1 hour duration. So that is the duration. If duration is 1 hour, then your rainfall, whatever the design storm depth you have got, or PMP value or SPS value you have, so that is also to be distributed in hourly rainfall. Okay, so if suppose your unit hydrograph ordinates a unit hydrograph is of 2 hours duration, then in that case, for convolution you need your rainfall excess ordinate also at every 2 hour duration. So here, because the principles of linearity and superposition has to be ensured when you are going for convolution. So this is very important. You have to keep that thing in mind. Now, how can you derive the unit hydrograph? From the observed hydrograph resulting from a storm which fulfills the 2 basic conditions. The rainfall is more or less uniformly distributed over the basin and has a reasonably uniform intensity. Such a hydrograph will generally form a single and short peak. But such type of events you are going to get very rarely obtained. In case such a hydrograph is not available, then the unit hydrograph has to be derived from the analysis of an observed complex storm. And for that, if you are having complex storm, then, hello?
I think some participants are having their microphone on. I request all the participants to please mute your microphone.
Yeah, please mute your mic. But if a single and short peak hydrograph is not available, then you can go for the complex storm analysis, and for that very good models nowadays like Clark and Nash, those are available, and using those, like if you are using Nash model, you can compute the N and K parameter using the complex storm. So like that you can verify. When the observed discharge and rainfall data at certain interval is not available, in that case, synthetic unit hydrograph can be used, and luckily in India, like when in synthetic hydrograph, there are different methods. Most of the people might be aware about the Clark method, then Nash also. But in Nash and Clark, the beauty is if you are having a observed data, then you can get their parameters, like what is the value of N and K in the Clark method. Basically, that's reservoir storage coefficient K. We can estimate time of concentration that you can estimate using the different formulas, which is given in the textbooks also. So, Snyder method was one of the very popular one. Then Taylor and Schwartz method was also there. Then SCS method, which is very widely used, but SCS method for small catchments, you can utilize this SCS method. For conceptual unit hydrograph like Clark and Nash for any type of catchment size that we can, but again in unit hydrograph theory, you have to keep in mind that unit hydrograph theory applicability is up to 5,000 square kilometer only. We are the 5,000 maximum 5,000 square kilometer. If the, but depending upon the slope also, if your catchment even is having only 5,000 square kilometer area, but the slope is very steep, then perhaps you have to divide your that catchment into number of sub-catchments of 1,000 or 2,000 square kilometer, and using the quasi-distributed hydrological modeling, you should estimate your design flood. Then comes the probability distribution function, PDF based methods like this. We are using gamma distribution functions to get the GIUH. That is also one of the methodology. Because nowadays using the Elvis, you can estimate the steep parameters like this Harton parameters, all those things, what is the elongation ratio, all those things, what how many first order in stream, second order. So now these GIS techniques are there. So earlier these computations were not possible. So using that methodology also, once you have got, then you can make the GIUH. Okay. Then another, if you are having the unit hydrograph and at one location, then you can transpose that unit hydrograph to another location, provided that the physiography and meteorological conditions are almost homogeneous. Then you can use that methodology also. Then Central Water Commission along with, because the data was provided by the Ministry of Railways and Ministry of Surface Transport, and all those data were collected, and based on use those data, flood estimation reports using the Snyder method. This flood estimation reports has been prepared, and these are, because here a lot of data has been used, and using that data we have gone for the regression, and using those regression equations, all the coefficient has been worked out. So this is a very useful publication to estimate the synthetic unit hydrograph at a particular location. So for this purpose of publication of this flood estimation reports, this country has been divided in 26 hydrometeorological homogeneous subzones. And for Andaman Nicobar, we could not publish, and for even southern Brahmaputra, we could not publish. The rest of the area, it has been published, and those flood estimation reports are available on CWC website, and that you can easily download. Like North Brahmaputra, it is flood estimation report number 2A. In Narmada, Upper Narmada and Lower Narmada, flood estimation report number 3A, 3B, like that, Godavari. So like in all those, for all those river basins, these flood estimation reports are available, which you can download from us. Now, this I've already explained. Now, whenever you are going for the design flood analysis, nowadays, now you see digital elevation models, DMs are available. So these DMs, even 90-meter DM is good enough to estimate the catchment area. If the catchment area is very small, or you are seeing a lot of variability in the geography of the catchment, then you can go for 30-meter or further, but even 90-meter is sufficient. And large catchment, suppose if I am going to map the entire Brahmaputra at say Guwahati, so I will go for 90-meter, that is more than sufficient. Little bit here, their catchment area, suppose the catchment area there we are getting 4.2 lakh square kilometer at say Guwahati, near the Guwahati, and using 30-meter you are getting 4.17 or 4.18. So whenever you are estimating the design flood or some hydrological parameters, so some in such a 1% or 1.5% variation is hardly going to matter in terms of hydro. So for now, because of these GIS advances, so it is very easy to map the catchment area. Then you can, once you have mapped the catchment area, then you have to compute the longest main stream length, that is called L. Then you have to estimate the centroidal point of the catchment area. What is the centroid? And once you have got the centroid and longest flow path, so from centroid, if you put one perpendicular on the longest flow path at the point, so where this point are meeting, so from that point up to outlet, whatever length we are getting, that is called the centroidal longest flow path. So this L, LC, and uh, equivalent steam slope along the longest flow path. And even if you click at for river bed profile along the longest flow path, then you will get the bed profile of the river, and that data you can transfer on the Excel, and from there you can calculate the equivalent stream slope. So equivalent stream slope, longest flow path, and centroidal longest flow path, and catchment area. These are the important parameters for estimating the unit hydrogram. Like I'm showing you this, like RGIS one catchment, that Bhairwa Dam. This we have estimated, and here catchment area is 117 square kilometer. This longest flow path, if you see, this is a elongated catchment. So longest flow path is 30.5 kilometers. This centroidal longest flow path is around 13.5, and equivalent stream slope based on the river bed profile along the longest flow path that we have computed, that is around 11.05 meter per kilometer. And how you can estimate the ESS, that you can see in our flood estimation report. It is given. And in general, in flood, now this I'm showing you through one example of this Bhairwa Dam itself. So now I'm having all these parameters. Once I've got all these parameters, now based on the location of the dam, catchment, I'm knowing, we have seen our flood estimation reports. Which flood estimation report shall apply here? So this catchment lies in 1G. So using 1G subzone of FER, you can get all those parameters like time to peak, and then QP means per square kilometer, what is the peak of the unit hydrograph, then the time base of the unit hydrograph, then width of the unit hydrograph at 50% of the peak value, width of the unit hydrograph at 75% of the peak value, then from center line from the peak, you have to see at 50% of the peak value, what is the width of the unit hydrograph from the, if you draw a center line from the peak. So like that, all those parameters you shall be able to estimate. So you will get these things like that. Yeah, I have got the time to peak TP is equal to 3.58, peak discharge of the unit hydrograph per square kilometer. Here unit is also given. W50, width of the rising side of the unit hydrograph measured at 50% of the peak discharge. WR50, width of the rising side of the, R means rising side, at 75% of the peak discharge. So now you have got all these parameters. Using these parameters, now you are going to get total 1, 2, 3, 4, 5, 6, 7 points, and these 7 points are marked. So using these 7 points, you can plot a graph on Excel, and then you have to further convert that graph into, first we plot it, then you have to make it in a well shape, and while making the well shape, you have to ensure that these points which are marked, their location should not change, their value should not change. So with respect to time, with respect to discharge, that value, rest of the things you can play. And then finally you have to test what is, suppose your catchment area you have got in this square kilometer. So catchment area, the sum of the ordinates should be equal to the catchment area divided by 0.36. Okay, if you are making a 1 centimeter 1 hour unit hydrograph, then your sum of the ordinates of the unit hydrograph should be equal to the catchment area in square kilometer divided by 0.36. So this is the test, this is the check whether your unit hydrograph is proper or not, and you have to see shape should come as a well shape. So like this, if you see, if we have got the ordinates, 7 ordinates, that is in blue line, and then we have adjusted and we made a bell-shaped, beautiful unit hydrograph, what you are seeing, the red line, and some of the ordinates, that is, you see the check 325, its catchment area is given in the square kilometer, divided by 0.3, it will come in 325, and the sum of the ordinates is also coming 325. It means whatever the hydrograph I have made, this is the unit hydrograph of 1 centimeter rainfall excess of 1 hour duration for the given catchment. Now, once you have got the unit hydrograph, then you are having the PMP atlas. So, from the unit hydrograph, if you see here, the base of the unit hydrograph is 20 hour. So, I have to consider a storm depth of at least 24 hour depth. And this project qualified for SPF. So, we have using the PMP atlas, we have estimated what is the 1 day SPS depth, and 1 day SPS depth from the PMP atlas of the Ganga, we have got 45.67. Then for hourly, in India, what happens if you see, if you analyze the rainfall data, whenever very severe storm is occurring, you must have seen there is a peculiar type of phenomena. In any 12 hours, the rainfall will be something around 60 to 70% of the total rainfall. So that's why in India, because of this phenomenon only, in 12 hour, the rainfall is occurring 60 to 70%. So bell theory has been evolved. So in bell theory, what we do in this 24-hour rainfall, we further break into 12-hour bell. Okay. So once you have break into bell, so for each 12 hour, you will get at 24 hour. Once you have got the depth and you have got the 24 hour that I will show you through table. Okay, how now this is the 24. This is you have got the 24-hour rainfall depth. Now for 24-hour distribution coefficient is also given in our PMP atlas. In that distribution coefficient, what you are seeing are given in the bold 70.4%. That is the rainfall occurred in 12 hours, total 12 hours. So it means in 12 hours, this 12-hour rainfall is around 70.4% of the 24-hour rainfall. So you have got, suppose your 12-hour total depth is say 200 millimeter. Okay. And at 12 hours, we are getting 70%. So what will be the first 12-hour depth? That will be 70% of the 200 millimeter. Means that will be 140 millimeter, and in next 12 hours, that will be 60 millimeter. So like that, 200 millimeter shall be distribution. Now, you have got now every 12 hours. So for each 12 hours, now you have to use the normalized distribution coefficient, because now you have got the absolute depth value, 140 millimeter. That is the 70% of the 200 total 24-hour rainfall. So now you have to normalize this. So how can you normalize? Divide each ordinate by 0.704. So you will get the normalized distribution coefficient for 12-hour bell. And now this distribution coefficient shall be used for the rainfall distribution and effective rainfall computation. Now, important aspects, key design loss rate. Once you have got the hourly rainfall, then from that hourly rainfall, you have to subtract the loss to get the effective rainfall. So design loss rate is also given in the flood estimation reports. So for that particular flood, you have to use the design loss rate of that particular subzone. So like for this project lies in FER 1G, and there the design loss rate at 0.27 millicentimeter per hour is given, so that you can take. And base flow is also given, that is 0.05 meter cube cubic per square kilometer. So these are the recommended, those values you can adopt. How we are going ahead further? Once we have got all those things, to convert 1 day rainfall into 24 hour rainfall. What is the difference between 1 day rainfall and 24? This is very important, that everybody should listen it very carefully. I think somebody is speaking. Please keep your mic off.
ಸರ್ ನಿಲ್ಲ ಸರ್ ಮನೋಹರ
Somebody
ಸಾಧ್ಯ
speak.
ಮಾತಾಡ್ತಾರೆ.
There is a lot of
ಮಾತಾಡ್ತಾರೆ.
noise. Somebody speaking.
ಏನು ಮನೋಹರ ಏನು ವಿಷಯ? ನಮಸ್ತೆ.
How can you go ahead convert 1 day rainfall into 24-hour rainfall based on the time distribution coefficient of 12 hour for the corresponding subcatchment from the PMP atlas? 24-hour cumulative rain is divided into two belts of 12 hour each. Then convert first 12 TD coefficients into normalized TD coefficient with respect to TD coefficient corresponding to 12th hour TD coefficient. Then distribute the 1 hour rainfall. Then from that you have to deduct the loss rate to get the effective rainfall. And once you have got the effective rainfall, then you have to go for the critical sequencing. And then after once you have done the critical sequencing, then you have to go for the convolution. Other people who are keep their mic on, please switch off their mics.
ಅಲ್ಲೇ ರೇపు ಏನ್ ಬಂದ?
Mr. Mali Venkateshwarlu, Mr. Mali Venkateshwarlu, please make your mic off. Mr. Venkateshwarlu, Mr. Venkateshwarlu, please make your mic off. Is disturbing the faculty, please.
Okay, thank you. So now you see here in this case, 1 day aerial SPS rainfall from the PMP atlas, we got 45.67. Now we are converting in 24 hours. Most of the people will say that 1 day is equal to 24 hours. Why you are converting in 24 hours? But fine, we are doing that. You see, the rainfall is measured at 8 a.m. Okay, so 8 a.m. to 8 a.m. that is 1 day. But the 24 hour could be 9 a.m. to 9 a.m., 10 a.m. to 10 a.m. of next day, 11 a.m. to 11, 1 p.m. to 1 p.m. So that is the difference, because 124 hour that we shall calculate in 24 hour from any hour. It is not from 8 a.m. to 8 a.m. next day. No. Okay. It will be from any hour to any. So that is the 24 hour. So normally this data has been analyzed, and what we have found is this may be 12% to 20% variation. Means if we consider this one day rainfall compared with 24-hour rainfall, the 24-hour rainfall was of the something around 12% to 20% more than the 1 day rainfall. So that's why 1 day rainfall is converted to 24-hour rainfall, and for that we apply a clock hour correction of about 15%, because this range was something around 12 to 20%. So just one average value of 15% has been taken. So again, there is a restriction. We suppose here 15% of 45.67, it shall be more than 50 millimeter. If it is coming more than 50 millimeter, then you have to apply the correction of only 50 millimeter. That's why what you are seeing, 45.67 plus 50 millimeter has been added, because 15% was more than the 50. So that way we have now got the 50.67 at 24 hour. Now first 12 hour belt depth, we have got 70.4% of 50.67, that is 35.67. Then depth of second 12 hour well, we have got 15 centimeter. Once you have got, then using the normalized distribution coefficient, now we are getting the cumulative depth, and from the cumulative depth, just from the 2 hour cumulative 2 hour rainfall, deduct the previous 1 hour rainfall, you will get the this incremental rainfall of each hour. So like what you are seeing, we have finally we have got incremental rainfall also. Then you have to deduct the losses from each belt, and after deducting the losses, what we have got, that is the effective rainfall. This effective rainfall, now you have to go for the critical sequencing. What is the critical sequencing? In critical sequencing, what we are doing, we are putting the highest value of the effective hourly rainfall against the highest value of the UH ordinate. Then the second highest value of the effective rainfall shall be placed against the second highest value of the UH ordinate. So like that, all the 12 values you have to put here, and once for each belt. And after that, you have to reverse the sequence. Once you have reversed the sequence, after that, Either you can go for the convolution using the B1 or B2 sequence, or B2 or B1. B1 means bell 1, B2 means bell 2. So any sequence you can use. And if you see the convolution, so this is the convolution table. Here the convolution has been carried out. What you are seeing, this is the time. And on second column, we are giving UH ordinate, and what you are seeing, the effective rainfall in centimeter. Those total 24 ordinates are there. And because there is a lag of 1 hour for in the two rainfall events, because these are the hourly incremental rainfall. So 1 hour lag you have to give, and then you have to add the entire thing to get the direct runoff hydrograph. Now in this catchment, the base flow was 0.05 say cubic per kilometer square. You multiply with the catchment area, we have got the base flow. Now you add the DRH ordinate with the base flow. That way you will get your design flood hydrograph, that is the SPF hydrograph for this case. And here the SPF value is something around, the peak value is at 1183 cubic. So this is the plot of the flood hydrograph. So that is the way we are doing it for single catchment. Now, things here up to here are quite now. Another case, now I will explain you. This is very interesting case, and most of the people you might be knowing about the Sardar Sarovar project of the Gujarat. This is a very large reservoir, and the catchment area is also quite large, around 88,000 square kilometer. And this is a concrete gravity dam having the length of around 1.21 kilometer, 1210 meter. And maximum height is around 163 meters, and the catchment area of the river Narmada at the project location is around 88,000 square kilometer. Its full reservoir level is 133.68 meter, maximum water level is around 140.21 meter. Its minimum drawdown level is 110.64. Gross storage is 9.5 billion cubic meter, that is huge one. And live storage is around 5.8 BCM. And when this dam was planned at that time, our BIS code, this IS 11223 1985, it came into 1985, and all these calculations were carried out in year 1980, 1978. At that time, because BIS code was not there, there was no standardization regarding adopting the design flood. So this time was, at that time, designer used to take either 500-year return period flood or 1000-year return period flood. And at that time, there is one around 12 kilometers downstream of this Sardar Sarovar project, one weir location is there, that is called Garudeshwar Weir. And at that location, long-term observation data was available, around 40 to 45 years data was available during the year 1980 also. And using that data, this using flood frequency approach, 1000-year flood of 87,000 cubic was estimated, and this was its value was around 30 lakh cubic in cubic, and the project spillway was designed corresponding to 87,000 cubic. But after the BIS code, then the World Bank, because World Bank was financing for that project, so World Bank people also made a lot of effort. Different experts were involved, and they finally estimated a probable maximum flood of 1,71,000. This is 1,71,000. There is mistake here, typographical error. This is showing 17,100. No, it is 1,71,000 cubic. It was almost double of the 1 in 1,000-year flood. Okay, just 3 years and around 4 years before this project authority, they contacted, because their DSRP recommended that its design flood should be reviewed by Central Water Commission, and the values of 1,71,100 cubic given by the World Bank experts seems to quite high. So we have gone through the data and all the records, because we told Center Water Commission we request the project authorities to provide us all the previous records so that we can go through that how this flood of 1,71,000 cubic was estimated, and from those records what we have found in summary that I will give key Dakor, there is one place Dakor that is near the coast in coastal area of the Gujarat, not exactly near the coast, but around 70 to 80 kilometers from the coast. And in that area, one storm occurred in year 1927. And that storm was used to estimate this design flood, and there were different estimates. A lot of calculations were carried out, and based on that, this flood of value of 1,71,100 cubic was given. And then we studied whether this Dakor storm should have been considered or not, because now since year 1906, and at that time also because IMD was also involved in that, then the director of IMD, he didn't agree with the World Bank experts regarding selection of Dakor storm, because his view was he had given his things in writing that later was available with us when we gone through the record. In his opinion, whatever they are considering these World Bank experts, I think that person was from Mexico, something like that, and he was not well aware about how the storm tracks move in India, because that is very important. India is the only country which is having a proper movement of storm tracks, and for that our IMDs are very proud to say that our IMD is having all the track records of the historical severe most storms. So if he had gone through those, like what you are seeing, that here, on 23rd July 1927, because one storm was occurred from there, Bengal, and this Dakor storm, this was because of, this was not from this storm, this was another storm, and because when this storm was near Kuna, so it, Umaria, then it attracted some moisture of the Arabian Sea also, but that moisture came up to Dakor only, and a very heavy storm occurred. But this storm was entirely different. So, and it is very well written in our PMP Atlas also, in this track of this storm. Using that one, I have made this slide diagram, what you are seeing here. And this is the catchment area. In that catchment area, what you are seeing of this Sardar Sarovar project, around 80,000 square kilometer. So, then when we got all the record, we have gone through that, and then we made a brief note about that, what was the follies were in that estimate. Then we estimated, and one more thing is very important, because at that time this one data is very important. That is the dew point temperature data. Now, like in Center Water Commission, in our wherever we are having our observatory, so we are measuring the wet bulb temperature also. That is very, because that is showing that data is very important, because people who are attending from the field, they should keep in mind your wet bulb and dry bulb temperature. That is very important data, because that gives us the very important parameter for PMP estimation, that is the moisture maximization factor. So that dew point, because sometimes people don't know why we are observing both data. What is the use of that? That is used to estimate what is the representative dew point temperature when a severe storm occurred. And using that dew point temperature, if you are having records of 40 years, then you can know in 40 years what was the maximum dew point temperature at this location. During that fortnight, suppose some storm occurred on 28 August, then we will see from 16 August to 31st August, what was the historical dew point data here. So that using that data, this moisture maximization factor is computed. And this is very important thing for computing the probable maximum precipitation. So here what we did, we used the PMP Atlas of Narmada, and then the flood estimation report of lower Narmada and upper Narmada. And now luckily this storm representing persisting dew point temperature data, historical dew point temperature data, everything is available in our PMP Atlas and big data record. When these people analyze at that time, because dew point temperature data was not available, so on whatever the records were available on that data, they have carried out again frequency analysis. In frequency on temperature data, using the frequency analysis is not advisable, but since the data was very sparsely available, so with the available data, whatever they have carried out at that time, that was okay. I will not put any comment on that, but at that time, because limited data was available, and whatever the best possible. Only thing I have reservation, whatever the storm they have selected, its type, its location, its transposition was completely wrong. That should, and IMD had clearly pointed out at that point of time, whatever you are selecting, I don't agree with you, but yes, take a World Bank is World Bank. They are experts. They because a lot of people from other countries are also coming, and they have very little knowledge about the meteorological phenomenon in India, hydrological phenomenon in India. So they whatever they are observing in their country, so their thought process may be going like that. So that was the reason might be the reason. Then here, the best thing, the area for transposition, if you see, because this is a large catchment, so there is WMO guideline, and this guideline is applicable for every country throughout world. It is followed. So what is given here? If you go as per WMO guideline, what WMO guidelines say, keep for nearly flat region, transposition can be considered up to 2 degree by 2 degree. Okay, means suppose you make a square and put a point in the center. So up to 2 degree on either side, east, west, north. You can 2 degree means something, and in India you can consider up to 200 kilometer. So up to 200 kilometer east of your location or west of your location, north of your location, south of your location, sparing the Himalayan region. In the plain region and considering other key, there should not be any barrier. Any storm which are occurred that can be transposed in the project catchment to estimate the probable maximum precipitation. Then there is another thing in the nearly flat region, but in the mountainous terrain, this is restriction. It should be 0.5 degree by 0.5 degree to 1 degree by 1 degree. This is para mentioned as per WMO 1986. Now, coastal storms means storms having centered west of Western Ghat and east of Eastern Ghat were not transposed to the catchment located far inland, because that is the phenomena, the orography of the nature, and because of the barrier, we cannot go beyond that. So, coastal storm, we can go up to 50 kilometer, 100 kilometer, but not beyond that. So, all those things, whenever you are going for PMP analysis or transposition, so this you have to keep in mind. No, if it is like Dakor, characteristic was like coastal storm, so I can use Dakor for Kadana, but I cannot use Dakor for the this Sardar Sarovar project for Narmada, because in that case, here the restriction is 200 kilometer, and these people, they transpose up to 540 kilometer. So that was completely a nonsense. That should not have been done like that. Considering the above governing criteria, several stops of PMP of the project catchment were selected. Again, in WMO, it is very clearly written, transposition to catchment larger than 50,000 square kilometer may result in unrealistically excessive PMP estimate. This may result in a severe unrealistic situation of flooding that is not experienced by the catchment. So all those precautions are given. So you have to, whenever you are going, because for existing structures, your design, whenever, like in the last 3 or 4 years, we had carried out design flood analysis on more than 300 projects in Central Water Commission. And we are very careful. If we are getting something very unrealistic or very excessive, then we check our calculation at least 2 or 3 times. Then we carried out calculation using other unit hydrograph like Clark and other things. Then we checked what it seems to be, because for existing projects, for new projects, it's okay. But for existing projects, making additional spillway, that is really involves a lot of expenditure. So all those computations should be carried out very thoroughly. So what we have done, like catchment area we have delineated for each catchment, its physiographic parameters we calculated. For each subcatchment unit hydrograph has been prepared. Then we have considered, because that was the most important part, selection of the critical storms that we have considered. So here we have considered these storms: 3-day Gharan storm dated 13th to 15th September 1998, then 3-day Golconda storm dated 4 to 6 August 1968, 3-day Dakorim storm. This we also considered. Why we have, I have written, though this cannot be considered as per WMO guidelines. However, since it was adopted earlier by the World Bank people, so only for computation purpose, to verify the computations, we have adopted this. And 3-day Panchmani storm. So here, this 3-day Dakota storm, this cannot be transposed. All other storms can be transposed as per WMO criteria. Now, these are the locations what you are seeing. This is the Sardar Sarovar project. This is the Golconda storm, and whenever I am bringing this storm from here to here, then you can see whatever seeing in the here at this location. This is the barrier. So barrier correction factor has to be here also. One hillock is there, so that will act as a barrier. That Dakor also, but no barrier correction factor was applied. And there was another storm, Panchmadi, Garandengri, all those were just inside the catchment only. So this can be very well transposed in the catchment area to estimate. Now, whenever we are selecting, though, our storms should be, it should cover the entire catchment. And you are seeing this is elongated catchment. But when we use Garandengri storm, so here what you are seeing, that then fall depth at I, 3-day. In 3-day, total depth at I at Garandengri. Garandengri storm means ki I of the storm was at Garandengri. Okay. So this is the Garandengri location, what you are seeing in situ location. This is the I location. In center of at the I, the rainfall depth was 1086. After transposition, what we found, the catchment representative transposed depth is 181.6 millimeter only. Now, 3-day Golconda storm, if you see, this is far better than that, because if you see, rainfall depth at I, it is less than the previous one, 19977, but if you see, ISO height very widespread and covering the entire catchment area. And here catchment representative, here transposed depth 282.4. In earlier one, we were getting 181.6. Here we are getting 282.4. And transposition adjustment factor. These factors, you please, because here the time is short, I cannot explain all those things, but you please download our PMP address and how these factors are calculated, it is given. So that is called transposition adjustment factor. So transposition adjustment factor, I will tell you, first you have to get the transposed depth, then multiply that transposed depth with the transposition adjustment factor. That will give you the SPS at that location, standard project storm. Now multiply that SPS with moisture maximization factor, that will give you the PMP value. So that is why these factors are. So here catchment represented PMP, we have got 285 millimeter. Now this is the 3-day Dakor storm. So Dakor storm up to where we can transpose, that we have also calculated. And here the catchment representative transpose depth we have found around 203 millimeter. Then 3-day Dakor, this storm critically transpose 1927. Now we have transpose. Here the catchment representative PMP we have got 331, TAF 0.76, MMF 1.40, MAF about 1.06. And here what we are getting MAF 1.06, but they have taken the MAF 1.35. Around 30% more. Okay, so that was one of the region. But actually it is 1.06 because at that time this dew point temperature data was not available for such a large period. That was the reason, because they used frequency analysis to estimate the maximum dew point temperature. That was the reason. Now, 3-day Panchmani storm, this is very ideal storm. If you see here, for what I have seen here, that in this, you are seeing this for every subcatchment. We have made total 52 subcatchment. For each subcatchment, the number of subcatchments are getting good amount of PMP values. So almost uniformly distributed, and it is covering entire subcatchment. And it's after rotation, what we are perfectly aligning this storm along the flow of the along the catchment also and along the flow of the river also. So here we have got catchment represented PMP 298 millimeter, and about 30 subcatchments are having PMP value of more than 300 millimeters. So a 3-day storm is sufficient and 5-day storm is not required. Now, this is the detail of Panchmani storm. So using all those storms, we calculated the PMP values. Like these are the unit hydrograph of all the subcatchments, and for each subcatchment, now I will show you directly. Now, once we have got all these parameters, PMP value, then we have made the quasi-distributed model. This is a quite, you are seeing perception of model, a lot of elements are there because there are 52 subcatchment, 38 channel routing reaches. To get the critical estimate of PMF, no reservoir routing from the upstream projects has been carried out because we wanted to estimate the maximum flood. Though Indira Sagar project is having huge storage and it could be used for the reservoir routing, but since there is no dedicated flood cushion in the Indira Sagar project, hence to estimate the probable maximum flood of the downstream project, no reservoir routing should be carried out. If I did got the dedicated flood cushion, then considering that one, we could have gone for the reservoir routing. So that's why we have done. Then about 208 kilometer reach of SSP reservoir, this Sardar Sarovar, having 7 routing reaches, and 43 kilometer reach of the Omkareshwar reservoir having 2 routing reaches, and 57 kilometer reach of Indira Sagar project, because these projects are in cascade, of ISP having 2 routing reaches, and 90 kilometer reach of Bargi reservoir having 1 routing reach. Lag channel routing having only translation and no attenuation has been assumed. Here again we have considered a very actual condition ki support, because here the things are in cascade, and how much Sardar Sarovar is going to get, that information it will get from the Indira Sagar project. So at that time, if you in the most critical condition, it will keep its gates open and whatever, and it will not allow the water level to go further. It means inflow is equal to outflow. It means that there is no further storage in the reservoir. Only some minor storage will be in the backwater form. That is for few hours only. But that is not going to play any role in the attenuation of the flood peak. Only thing, yes, I have released something, some quantity of flood from Indira Sagar project. It will reach at Sardar Sarovar project after 6 hours or 5 hours. So that is called the translation part, means translation travel time. There is no attenuation. Then critical loss rate we have considered 1 millimeter per hour and base flow 0.05. So all those things we have considered critical, and you will see these are the lag routing parameters, and rest of the river reaches we have considered the Muskingum routing parameters, and here also we have ensured ki in Muskingum routing delta T means time steps. If your flood hydrograph or ignite start at every 1 hour, then delta T should be greater than or equal to the 2 kx, where k is the travel time and x is one of the paying parameter. ठीक है, तो x hardly matters, important thing is k, but delta t. So for that, suppose my routing reach length is 70 kilometers. So in one go I cannot carry out the routing, because what then the routing algorithm is going to be unstable. Like in hydrodynamic routing, you might be knowing the current number. Same way here, delta t should be greater than 2ks if it is working as a current number. So you have to divide that routing reach into number of sub reaches, and what you are seeing, the number of sub reaches, how many number of sub reaches has been used, that is given. Okay. So estimated PMF using Goldkund storm, and here what you are seeing, what is the peak discharge, what is the volume associated, everything we have calculated. This is from Panchmani storm. Again, what you are seeing here, what is the peak discharge and what is the now. These are the other upstream location. If I am putting my storm like that one to get the maximized depth, then at ISP, at Bargi Dam and Maheshwar, what will be the flood hydrograph? Because this is integrated model, everything you can get. Now, so using the Dakor storm also be calculated. Then sensitivity analysis we also carried out by changing the loss parameter and all those things. And this is the important part we have tabulated here. Goldkund storm, Lang and Muskingum, routing method, loss rate 1, then we are getting 86,000 and volume of the flood hydrograph, that is both, because this is storage project, so not only P, you have to consider how much volume is associated with that, around 21.52. 3-day Panchmani storm, one. Now, if you see here, corresponding to Dakota storm, we have got 1,06,974. Corresponding to Panchmani storm, here we have got 1,04,000 square kilometer. It means earlier estimate was 1,71,000, that was wrong. And since the core storm cannot be adopted, so what we have clearly written from Central Water Commission side, whatever the earlier study was carried on the World Bank, that should not be adopted at all. Their experts could not understand the Indian meteorological phenomena, and your revised PMF is now of the order of 1,03,700 cubic. Okay, so that has been now adopted, and we have carried out further analysis using the flood frequency using Garudeshwar BR also, and here we have got 1,09,000 value. So whatever 1,04,000 and another important associated volume, if you see here, corresponding to 1,03,000, around 26 BCM. And here in the case of Dakor, storm 26.8, here 26.4, both are comparable. So that's why we have told that now your PMF you should adopt 1,03,700 cubic, and using that for most critical condition also, what we have 10% gates, because it is in given as per in BIS code if there are 30 gates, you consider 3 gates inoperative, because that possibility may happen. Some of gates you might not be able to open, so you consider 10% gate inoperative, and using 10% gate inoperative also we have carried out this reservoir routing, and what you see here the maximum water level is going something around 141.2 against the top of dam is 146.50. So what we have told, your dam is hydrologically safe. Please, that whatever the value was earlier adopted, 171, because this spillway was designed for 87,000. No further increase in the spillway capacity is required, and earlier estimated design flood was not proper because the storm was selected, the water was not selected, that was wrong one, and its parameters estimated were not appropriate. So now using the different scenarios, sensitivity analysis, and all those things, what will be the upper limit and lower limit, then 1,04,000 cubic is the sufficient. That is the good estimate of the probable maximum flood. So conclusion, proper selection of storm depth for design flood abuse should be ensured. For small catchment, the storm depth values may be adopted from PMP atlases published by Central Water Commission and IMD. For large catchment, selected storm should be transposed, and SPS/PMP values should be computed after applying necessary adjustment factor like location adjustment factor, barrier adjustment factor, and moisture maximization factor. Transposition to catchment larger than 50,000 square kilometer may result in unrealistically excessive PMP estimates, and this may result in a severe unrealistic situation of flooding that is not experienced by the catchment. Hence, in case of large catchment, the utmost care should be taken in storm selection and transposition for PMP computations. A rational selection of storm considering the storm track, means how storm generally moves in India, influencing factors for storm centering, and storm transposition limit needs to be decided carefully in order to obtain a reliable estimate of PMP depth over the subcatchments and consequent PMF estimate through a detailed sensitivity analysis.
इसको क्या है?
Thank you very much.
इसको भाई शनिवार शुक्रवार ये वाला एड्रेस डालिए ऑपोजिट तो ठीक है.
There is some noise. Please mute yourself.
So my presentation ends here. Now, if there is any question from you people, then you can ask.
Now the floor is open for question answer session. If you have any doubt, any question, any query, you kindly write down in chat box, or you can directly ask to our speaker, please.
I think there are already a few questions in the chat box. So Rai Sahab, please take the questions which
Yes,
are
it
already
is
there in the chat
required
box.
storage about 1 BCM is created. Can somebody read? Because just 1 minute.
Actually, the questions have started quite early. There is a question from Prabjot Singh.
Yes, sir.
Please tell us about Indus Basin. What should we do in case of Indus Basin?
For what? In Indus Basin, because in Indus Basin, the PMP Atlas has been published by IMD.
There is a lot of noise. Only please mute yourself, and only the participants who want to ask questions they can unmute and speak. Kindly all
Sharing,
participants mute yourself. There is a lot of noise. Thank you. If Mr. Prabjot Singh is online, he can unmute and speak. Prabjot Singh,
गुड मॉर्निंग,
you
गुड
have
आफ्टरनून
asked a
सर।
question about Indus Basin. Yeah, please go ahead.
या
सर एक्चुअली हमारा डाउट ये था कि अगर जो कैचमेंट एरिया है वो इंडस बेसिन में लाई करे तो उस पर्टिकुलर केस में सीडब्ल्यूसी ने जो मेथड डिफाइन किया है उसमें जैसे जो आपने लिस्ट दी है इंक्लूजन्स की ऑफ बेसिन्स उसमें इंडस बेसिन को इंक्लूड नहीं किया है, तो उसको हम किस परव्यू में देखें और उसको
नहीं,
कैसे डिजाइन?
इंडस बेसिन का भी वो इंडस बेसिन मैंने आपको बताया भी था ड्यूरिंग माय प्रेजेंटेशन कि इंडस बेसिन
आप
का
read करके
पीएमपी
जाइएगा, chat
एटलस
box में
दैट हैज ऑलरेडी बीन पब्लिश्ड बाय
मेरी बात
IMD.
बीच में सुनना।
It is available with the IMD and all the parameters are given in that.
ओके
So you can use
सर
the
एक
PMP Atlas of Indus.
ओके सर एक चीज और थी इसमें कि जैसे कैचमेंट एरियाज बहुत छोटे छोटे होते हैं हमारे,
हाँ,
लाइक एफईआर की रिपोर्ट में जैसे बताया हुआ है कि 25 किलोमीटर स्क्वायर से 2500 किलोमीटर स्क्वायर तक के कैचमेंट एरिया के लिए एफईआर 1E की या 7 की रिपोर्ट जो वैलिड है।
राइट.
तो अगर कैचमेंट एरिया आपका उससे कम है 25 किलोमीटर स्क्वायर से, तो उस पर्टिकुलर केस में हम इसकी डीएफआर किस तरह से देखें? क्या हमें राशन
तो
मेथड
उसके लिए
के थ्रू जाना
सबसे बढ़िया
पड़ेगा?
आपका अभी अभी मैंने एक ले में कोर्स कंडक्ट किया था, राइट.
ओके
उसमें हमने छोटे छोटे कैचमेंट में यू कैन यूज द SCS मेथड और डिपेंडिंग अपॉन द स्लोप ऑफ योर कैचमेंट उसमें PRF फैक्टर एडजस्ट करने का है. PRF 50, PRF 75, PRF 100. तो डिपेंडिंग अपॉन द स्लोप ऑन HMS के आपके मैनुअल में SCS मेथड के बारे में बहुत अच्छी तरह से एक्सप्लेन किया गया है. यूजिंग द किरपिच फार्मूला यू कैन एस्टिमेट व्हाट इज द टाइम ऑफ कंसंट्रेशन. वो टाइम ऑफ कंसंट्रेशन आप मिनट में कन्वर्ट करके वहां पे SCS में डाल दो. उसके बाद बेस्ड ऑन द PRF फैक्टर जैसा भी आप डिफाइन करो कि छोटे कैचमेंट के लिए SCS यू कैन यूज दैट.
सर उसमें मतलब राउटिंग की केस में मस्किंगम प्रेफर किया जाएगा एज अ मेथड या हम
छोटे कैचमेंट में तो आपका राउटिंग होगा ही नहीं. राउटिंग तो आपका यूज होगा बड़े कैचमेंट में ना. छोटे कैचमेंट में तो आपका लम्पटल जहां पे लम्प्ड आप मॉडल बना रहे हो सिंगल कैचमेंट, तो वहां पे राउटिंग इज नॉट रिक्वायर्ड. लेकिन यस, कहीं पे भी राउटिंग करनी हो तो यू कैन गो फॉर द मुस्किंगम मेथड. और अगर आपके पास एक दो क्रॉस सेक्शन है तो मुस्किंगम कुंज मेथड भी है.
ओके सर, एक्चुअली मेरा क्वेश्चन इसी के रिगार्डिंग था कि हमें एस्केप चैनल को डिजाइन करना है, तो एस्केप चैनल को जब हम डिजाइन करेंगे तो दैट पीक नीडेड अबव द एनसीएल जहां पे हमें इंपेंज कराना है फ्लड को, तो वहां हमारा डाउट एक्चुअली.
तो उसमें आपको क्या करना है कि पहले उसके इनलेट पे कि कितना फ्लड आ रहा है दैट यू आर गोइंग टू एस्टिमेट. पहले वो आप एस्टिमेट कर लीजिए. उसके बाद स्केप चैनल है जो भी उस पोर्शन का, देन यू शुड हैव द क्रॉस सेक्शन एंड यूजिंग दोज क्रॉस सेक्शंस. और आपके पास फ्लड की वैल्यू आ गई, फ्लड हाइड्रोग्राफ आ गया, इवन फ्लड पीक के करस्पॉन्डिंग. सपोज ये फ्लड पीक यू आर गेटिंग 400 क्यूबिक या 300 क्यूबिक, तो 300 क्यूबिक के अगर 300 क्यूबिक का फ्लड मेरा आ रहा है डिफरेंट लोकेशंस पे वाटर लेवल जाएगा. दैट यू कैन एस्टिमेट यूजिंग हेकरेस सिमुलेशन. उसके लिए आपको हेकरेस यूज करना पड़ेगा.
ओके सर, वन लास्ट क्वेश्चन मोर. सर अगर एक पर्टिकुलर पहले बराज बन रखा है पिछले 50 साल पहले या 60 साल पहले, और उसकी अपस्ट्रीम पर एक पर्टिकुलर गॉज पर डैम बना दिया जाता है,
हाँ,
तो उस पर्टिकुलर केस में मैं उस बराज के लिए डीएफआर को कैसे प्रिपेयर करूंगा? क्योंकि उस केस में तो ऐसा होगा कि अपस्ट्रीम में
Yes, very good question. उस केस में अगेन डीएफआर का प्रिंसिपल सेम रहेगा। मैंने आपको क्या बताया, इवन इंदिरा सागर जैसा डैम बना हुआ, लेकिन सरदार सरोवर के डिजाइन में मैंने ये मान के चला कि इंदिरा सागर है ही नहीं, क्योंकि डिजाइन फ्लड जब आप कैलकुलेट कर रहे हो तो क्रिटिकल कंडीशन के लिए कर रहे हो। और दूसरे जैसे आपका इंडस बेसिन में वो, जैसे आप बोल रहे या कहीं पे बैराज है, बैराज के ऊपर एक डैम आ गया, डैम में अगर डेडिकेटेड फ्लड कुशन नहीं है, डेडिकेटेड फ्लड कुशन जैसे हमारा दामोदर वैली कारपोरेशन के वो में दिया गया है, तो वहां पे आपको रिजर्वायर राउटिंग करने की जरूरत है। अगर डेडिकेटेड फ्लड कुशन नहीं है तो आपका कोई रिजर्वायर राउटिंग नहीं होगी, कुछ नहीं होगी, और उस बैराज लोकेशन पे फ्लड की वैल्यू जो है जैसे पहले आपने एस्टिमेट किया था उसी तरह से estimate
चलो ओके 64।
और सर अगर उसी बैराज और डैम के बीच में एक और बड़ा बैराज बना दिया जाए तो उस केस में
इसका
फिर क्या मैटर
इंडिपेंडेंटली आपको करना है। जैसे जैसे मैंने बोला ना, अनलेस अपस्ट्रीम में जो भी प्रोजेक्ट है उसका देखिए, डिजाइन फ्लड और फिलॉसफी अलग है, वाटर एबिलिटी में अलग। वाटर एबिलिटी में मैं अगर उस बैराज पे आऊंगा तो नेट वाटर नाउ अवेलेबल मैं देखूंगा, क्योंकि ऊपर वाला प्रोजेक्ट अगर डाइवर्ट कर रहा है पानी, कमांड एरिया में जा रहा है वहां से, तो उतना हम पहले विर्जिन फ्लो निकालेंगे, उसमें से अपस्ट्रीम में कितना यूटिलाइजेशन जो कर रहा है वो घटा के देंगे। लेकिन डिजाइन फ्लड में ऐसा कुछ नहीं होगा। डिजाइन फ्लड में जब फ्लड आएगी तो वो तो डैम वाला में छोड़ देगा आपका नीचे, आप तो मर जाओगे अगर आपने कैपेसिटी नहीं दे रखी है। डिजाइन फ्लड को दूसरे वे में करना है। डिजाइन फ्लड को एज इफ देयर इज, अगर डेडिकेटेड फ्लड कुशन नहीं है तो ऊपर कोई प्रोजेक्ट नहीं है, वो कंसीडर करते हुए यू हैव टू एस्टिमेट डिजाइन फ्लड। राइट, क्लियर?
थैंक यू सर, थैंक यू।
Okay. Sir, next question is, how can we get soft copy of PMP Atlas Western Ghat Kerala?
वो तो है ना, हमारे सॉफ्ट कॉपी हमारे सेंट्रल वाटर कमीशन की वेबसाइट पे है पूरा, जितने पीएमपी एटलस पब्लिश हुए किए सेंट्रल वाटर कमीशन ने, सारे सीडब्ल्यूसी के वेबसाइट पे है, वहां से आप जाके डाउनलोड कर सकते हैं, पीडीएफ फॉर्मेट में अवेलेबल है।
Sir, next question is, which all instrument we need to install with all these dew point temperature, wet bulb and dry bulb temperature? All instrument list please for early warning forecasting.
क्या क्या है?
What are the instruments required?
यस, तो वो तो आपका जो व्हाट इज पर्टिकुलर नीड, जो वेट बल्ब और ड्राई बल्ब टेम्परेचर,
That is the minimum instrument जो है आपके all weather parameters के लिए required.
नहीं आज वेदर, अगर सिर्फ वेट बल्ब एंड ड्राई बल्ब तो उसका तो
Wet bulb, dry bulb, thermometer.
वेट बल्ब ड्राई बल्ब थर्मोमीटर दैट विल बी सफिशिएंट। और जनरली जहां पे भी आपका मेट्रोलॉजिकल स्टेशन है आजकल, मीटर का पेन और ये आपका रेन गेज स्टेशन और ये तो मैंडेटरी, ये सारी चीजें तो हर जगह अवेलेबल है, हर जगह लोग इंस्टॉल कर रहे हैं। तो उसका वेट ड्राई बल्ब टेम्परेचर वाले बस वही दो आपको थर्मोमीटर चाहिए, नथिंग एल्स।
Thank you, sir. Next question is, any Excel sheet is available to arrive at PMP from our actual rainfall recording at site?
एक्सेल शीट क्या, उसके लिए कंप्लीट पीएमपी एटलस इज अवेलेबल। फ्रॉम देयर आई हैव ऑलरेडी शोन यू कि फ्रॉम पीएमपी एटलस यू कैन गेट डायरेक्टली द वैल्यू ऑफ पीएमपी और एसपीएस।
Sir, next question is very big one. I will read first. In particular river, there are two dams. Upstream dam is D1, is located in state X, and downstream dam D2 is located in state Y. The
Okay.
upstream dam owner is expert in hydrology. He has modern tools like HEC, HMS, SWAT, MIC, and access to various hydrologic, meteorologic, terrain data platform. And he developed a model to derive inflow design hydrograph at outlet D1. But he does not have direct flow measurement in upstream reaches, so he used to inflow series derived from the storage outflow characteristics of the upstream reservoir RD1 for calibration validation of his model, but he has not updated elevation storage curve of the reservoir RD1 that prepared about 60 years back during the time of design of the project. The revised flood peak estimated as per his model px meter cube per second the downstream dam owner is not that expert and not updated with the advances in field of hydrology. So he used FER 1992 and PMP 2015 Atlas adopted the procedure as per CWC to derive IDF of upstream reservoir RD1. His estimated flood peak was PY meter cube per second, and PY is greater than PX. PX is not acceptable for state Y and PY is not acceptable for state X. In such case, how to resolve this conflict and who will be responsible for taking the final stand on the correctness of the result as per the Dam Safety Act 2021?
Then this matter may be referred to NDSA.
Yes.
This matter, this is a best case. I think this relates to Mulla Periyar perhaps.
Maybe, sir.
If I am guessing it.
Yes.
So this
Sir.
may be referred, but as far as there is confusion regarding ki, suppose if I take the Mulla Periyar itself, so Mulla Periyar and then you consider Idki downstream. That I am giving one example. This I don't know from which region this question, but when the catchment area increases, then the aerial depth of the PMP will be less. Keep this thing in mind. Okay. So for Mulla Periyar, your PMP value will be little bit high, but in the case of Idki, the aerial value of PMP will be less.
Sir, next question is, the dams are designed for design flood discharge which will safely flow through the spillway below MWL. For overtopping the dam, what criteria for calculating lateral inflow should we take to know the inundation area during dam break in overtopping condition for the gates and without gates?
1 minute. The dam are designed for design flood discharge, which will safely pass through the spillway below MWL. For overtopping the dam, what criteria for calculating the lateral inflow shall we to know the inundated area during dam break in overtopping condition for gates and without gates? This, because this is very simple. No. Because dam break study is the hypothetical study. So normally we consider the whatever the design flood is there, that using that design flood, if the dam break is taking place, what will be the inundation, that and lateral flow. Suppose you are going for the 2D modeling, so already whatever the dam break flood is coming to with its attenuation, if there are two conditions. One condition is that there is no rainfall in the downstream. Another condition ki yes, downstream of the dam also some rainfall is taking place. So in that case, lateral inflow at different locations for each subcatchment. If some streams are joining for each subcatchment, you have to estimate ki how much lateral inflow is coming at that point, that you have to put as a boundary condition there. So that boundary condition along with the what happened during the dam break. So dam break flood plus reservoir depletion both will come just downstream of the dam, and it will automatically model will take care of that. But for the downstream reaches, lateral inflow shall be considered only for the intervening catchment, not for the entire catchment. Because for the entire catchment up to dam side, that has already been taken in the form of design flood.
Thank you, sir. Sir, next question is for Western. Yes. Yes, please. Yeah, please ask your question.
In a particular, what is in a part, there is only one river gauge and it is the downstream reach of the catchment.
Sir, next question is for Western Ghat west flowing rivers with catchment area of 2000 square kilometer, can we use PMP atlas for PMP values?
Yes, certainly you can use. For Western Ghat, it is given, PMP atlas is there.
Okay. Sir, next question. Do CWC has any studies carried out for flood in Western Ghat, west flowing Sharwati and Varahi river basin. Any links to download? Do CWC has river discharge and rain gauge stations in these basins?
Certainly, certainly, Central Water
Shravati and
Commission is
Varahi.
having, and on NWIC they can see all the locations.
Sir, next question is during routing, if inflow imping at FRL, then the outflow will be the discharge at FRL level. My question is inflow value will be from 1 hour or at that hour where the inflow value is equal to or just more than the outflow value.
Yes, very good question. This will be, inflow will be equal to the outflow. So your, suppose your hydrograph is starting from 0 hour, but inflow is equal to outflow at 8 hour in the rising link. Then you have to start your routing from 8 hour only. Any other question? Link.
Sir, next question.
Yeah.
If DFR for barrage is assessed on river channel, then would that DFR serve the purpose of another barrage downstream on the same river channel, as control outflow of upstream barrage will be the inflow for downstream barrage?
No. Control outflow for each barrage design flood has to be estimated independently. I've already told, in the case of design flood, no concentration of the upstream downstream barrage shall be taken into account. Only for the water availability computations, yes, that shall be certainly taken into account, but not for design flood computation.
Thank you, sir. Sir, next question is, as it was told that we cannot go for a lump model for even 4,000 or 5,000 square kilometer catchment area having higher slope. How
Yeah.
much slope we consider as higher slope in meter per kilometer?
I think if it is more than 30 to 35 meter per kilometer, if it is more than 30 kilometer, but depending upon there is no standard criteria, but based on my experience, I can say if the equivalent, like in Sikkim, you will get the equivalent steep slope of the order of 40 to 80 meter per kilometer. So that's why but if it is more than 30 meter per kilometer, then you can consider, then you should break down your catchment into sub-catchments. Any other question?
Sir, next
Yes, sir.
question is,
Hello.
Yeah, please speak.
yes,
Sorry
kindly ask.
सर सॉरी सर दोबारा वही क्वेश्चन जो आपसे पूछना चाह रहा था मैं एक्चुअली सर देयर इज अ प्रॉब्लम वी आर फेसिंग इन वी हैव अ केस फॉर द माधोपुर हेडवर्क्स एक्चुअली क्या था कि सर वो उसकी कमीशनिंग आई थिंक 50-60 साल पहले हो चुकी थी बट 100 साल पहले हो चुकी थी बट रंजीत सागर डैम जो है उसकी अपस्ट्रीम पर बनाया गया था सन 2000 में या 2001 में उसकी कमीशनिंग हो चुकी थी अब रिसेंटली क्या था कि 2014 से सर कंस्ट्रक्शन शुरू हुई शाहपुर कंडी बैराज की विच इज लाइंग इन बिटवीन माधोपुर अपस्ट्रीम ऑफ माधोपुर हेडवर्क्स एंड डाउनस्ट्रीम ऑफ रंजीत सागर डैम अब रिसेंटली सर वो फिलिंग उसकी स्टार्ट हो चुकी है तो वी आर एक्चुअली इन कंफ्यूजन दैट व्हाट नीड्स टू बी डन फॉर द डीएफआर ऑफ माधोपुर हेडवर्क्स क्योंकि
यस आई गॉट योर क्वेश्चन आपका कंफ्यूजन एक तो मुझे लगता है सबसे बड़ा ये कि रंजीत सागर डैम हैड बीन डिजाइन फॉर द प्रोबेबल मैक्सिमम फ्लड ओके
जी सर
तो क्या जो नीचे बैराज बन रहा है दैट शुड आल्सो बी डिजाइन फॉर द प्रोबेबल मैक्सिमम फ्लड
नो सर एक्चुअली एग्जिस्टिंग जो स्ट्रक्चर है माधोपुर हेडवर्क उसकी कैपेसिटी है 17,500 क्यूबिक
लेकिन वो तो आपको 1 in 100 के लिए डिजाइन होगा क्योंकि बैराजेज के केस में हम पीएमएफ नहीं कंसीडर करेंगे 1 in 100 के लिए आपका बैराज डिजाइन होगा
हाँ जी सर पर जो सर 100 ईयर फ्लड जो है बेसिकली अब वो डिपेंड करता है सर जो रिलीजेस होंगे रंजीत सागर डैम की तरफ से
यस तो व्हाट यू कैन डू कि पहले आप रंजीत सागर पे 1 in 100 ईयर का फ्लड एस्टिमेट कर लीजिए हाइड्रोमेट्रोलॉजिकल अप्रोच से ठीक है और उसके बाद या नहीं हाइड्रोमीटरोलॉजिकल से कर रहे हैं, अगर आप फ्रीक्वेंसी से कर रहे हैं तो फिर उससे एक हाइड्रोग्राफ आपको बनाना पड़ेगा। फिर उसको, क्योंकि रंजीत सागर डैम पीएमएफ के लिए डिजाइन किया गया है, तो 100 ईयर फ्लड को राउट भी कर सकता है, ठीक है। तो उसको राउट करके और कितना पीक वहां से आ रही है, प्लस इंटरमीडिएट कैचमेंट पे अगर उसी समय 100 ईयर का अगर रेनफॉल होता है, तो दोनों को ऐड करके देख लीजिए कितना बनता है, यू कैन डिजाइन फॉर दैट।
ओके। और सर एक चीज और थी कि जैसे इन बिटवीन अब शाहपुर कंडी डैम जो बनाया रिसेंटली, उसकी फिलिंग स्टार्ट हो गई है सर। उसका जो डिजाइन वैल्यू है डिस्चार्ज का, वो 21,500 क्यूमेक्स है, और पीएमएफ पर इसकी वैल्यू 26,000 क्यूमेक्स तक चली जाती है।
हाँ
और वो जस्ट आई थिंक 2-3 या 4 किलोमीटर अपस्ट्रीम है माधोपुर हेडवर्क से। तो
यस
उस पर्टिकुलर केस में क्योंकि इसकी रिलीजेस हमारे पास नहीं है और रिसेंटली ही ये फिलिंग इसकी स्टार्ट हुई है, तो अगर एक्सट्रीम कंडीशन में भी मैं देखता हूँ तो 21,500 क्यूमेक्स ज्यादा है इसकी डिस्चार्जिंग कैपेसिटी एज कम्पेयर टू माय माधोपुर हेडवर्क्स। तो उस पर्टिकुलर सर केस में क्या किया जाना चाहिए क्या? क्योंकि ऐसे तो सर एक पर्टिकुलर बराज के ऊपर तो हम जितने मर्जी बराज स्ट्रक्चर जो है कंस्ट्रक्ट कर लेंगे, तो फिर उस पर्टिकुलर स्ट्रक्चर की वायबिलिटी क्या रहेगी, या उसको हम किस वे में देखें, या उसकी डीएफआर करनी बनती भी है या नहीं? हम वहां कंफ्यूज होते हैं सर।
ये चीज, यस यस, दिस इज, ये इसका जवाब बहुत क्लियर कट मैं भी नहीं दे पाऊंगा। ये डिपेंड करता है कि डिजाइनर्स का क्या अप्रोच है। अब मैं फॉर एग्जांपल आपको बताता हूं कि जैसे ये कालेश्वरम प्रोजेक्ट था, राइट। कालेश्वरम प्रोजेक्ट में 3 बैराजेस थे, मेडीगड्डा बैराज था, लक्ष्मी बैराज था, सरस्वती बैराज था। तो उसके ऊपर एक श्री राम सागर प्रोजेक्ट, ठीक है। श्री राम सागर प्रोजेक्ट का कोई, जिसका जो प्रोबेबल मैक्सिमम फ्लड था, उसका जो प्रोबेबल मैक्सिमम फ्लड से चूंकि तीनों का कैस्केड था, तो ऊपर के 2 बैराजेस में हमने वही जो प्रोबेबल मैक्सिमम फ्लड की जो, सपोज प्रोबेबल मैक्सिमम फ्लड अगर उसका 80,000 क्यूमेक था, तो इनको ये बोला कि आपकी जो वाटर वे शुड बी डिजाइन फॉर 80,000 क्यूमेक। नीचे जब आए हम मेडीगड्डा बैराज पे, तो वहां पे एक प्राणिता रिवर और वहां पे कैचमेंट एरिया काफी बढ़ गया। तो वहां पे हमने पाया कि 1 in 100 ईयर की फ्लड जो है 80,000 क्यूबिक से ज्यादा हो रही है, क्योंकि वहां पे कैचमेंट एरिया बहुत बढ़ गया था। तो उसका जो भी 1 in 100 ईयर का आ रहा था, तो लाइक दैट अगर कैस्केड में ऐसी चीजें हैं, तो इन कंसल्टेशन विद द डिजाइनर appropriate design flood may be adopted. You got my point?
यस सर, बस अप्रोप्रिएट होगा क्या एक्चुअली, वहीं पर हम कंफ्यूज हो रहे हैं।
ये डिजाइनर्स का वो है। डिजाइन देखिए आपका, मैं आपको फॉर एग्जांपल बताऊं कि बीआईएस कोड में देखिए तो वाटर वे के लिए 1 in 50 ईयर बोलता है बैराजेज में, ठीक है।
जी सर।
लेकिन आजकल कोई भी नहीं ले रहा, हर कोई 100 ईयर ले रहा है। बड़े बैराजेज है, हर कोई 100 ईयर कम से कम लेता है। और उसका फ्री बोर्ड कैलकुलेशन के लिए कि जो भी जो आप गाइड बैंक देते हो वो टॉपल ना होने पाए, उसके लिए 500 ईयर फ्लड के लिए प्रोफाइल प्लॉट करके देखते हैं ये लोग। तो वो है
यस
वो
सर।
डिजाइन। हाँ, तो वो आई थिंक इट शुड बी डिजाइनेड इन कंसल्टेशन विद द डिजाइनर।
ओके। कैन वी से दैट कि जो इन बिटवीन बराज है, शाहपुर कंडी डैम है, वो जैसे पीएमएफ के लिए डिजाइन हुआ हुआ, तो उसके 100 हम क्योंकि वो जस्ट 2 या 3 किलोमीटर पीछे ही है सर उससे, तो
वो मैं तो बता रहा,
उसका
ये डिजाइनर से
100
आप
ईयर
लोग कर
रिजर्व
लीजिए
पीरियड में फ्लड
जो कि
देख लिया जाए।
इसमें अगर पीएमएफ छोड़ा गया। लेकिन ये भी होता है ना कि मतलब कॉस्ट इकोनॉमिक्स भी देखते हैं ये लोग। तो इसलिए मैंने बोला एक बार डिजाइनर से इसको कंसल्ट कर लीजिए। मैंने जैसे एक एग्जांपल आपको दे दिया कि वो वहां पे यूज हुआ था 2 बैराजेस के केस में कालेश्वरम प्रोजेक्ट पे। तो वेदर दे आर एग्रीइंग फॉर दैट आल्सो, तो यू कैन गो फॉर दैट।
तो जब से ये मैंने सिद्धिविनायक काम करना अपने पिताजी के लिए।
ओके, तो आई थिंक इज देयर एनी अदर क्वेश्चन? Milinji, can we stop here?
I think there are many questions in the chat box.
Yeah. So,
सर
One second. हाँ
मोस्टली दे दिए फाइनल। हाँ
सर, नेक्स्ट क्वेश्चन इज for catchment of 1400 and 800 square kilometer area, can we consider PMP atlas or can we consider maximum observed rainfall in the nearby areas?
नो 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 नो। आपको कितना था कैचमेंट एरिया में बताया?
1400 and 800 square kilometer.
Yeah, you should use the value given in the PMP atlas. Ideal for this. Not because you cannot take maximum observed in the area, because the PMP, if your dam is qualifying for the PMF, then what has happened in your area Only that doesn't matter. In that case, up to 2 degree, up to 200 kilometer, if anything has happened, that storm has to be transposed at your project catchment location. And PMP has been calculated like that. इसलिए you have to take the value from the PMP address.
Sir, next question is, sometimes when dams are in series, say Kundalia Dam MP on upstream of Kalisin Dam Rajasthan, then PMF is occurring with release of water from upstream reservoir. In that case, what will be the method of PMF in downstream reservoir? Similar is case of Gandhi Sagar Dam, RPS Dam, Jawahar Sagar Dam and Kota Barrage on Chambal River.
Yes. अब गांधी सागर is a different story. Gandhi Sagar is over the year storage project. Gandhi Sagar is having around FRL से ऊपर साढ़े around 3 BCM स्टोर कर सकता है. तो अगर आपको जवाहर सागर, राणा प्रताप सागर का लेना है तो उस केस में गांधी सागर का जो रिलीज होगा प्लस पीएमएफ के केस में probable maximum flood in the case of PMF what shall be released from Gandhi Sagar plus intermediate catchment that you can adopt. ठीक है. लेकिन अगर सेम चीज नर्मदा में वो फ्लेक्सिबिलिटी नहीं है वो उस पे, क्योंकि गांधी सागर में आई कैन से कि फ्लड कुशन इज अवेलेबल इन अनदर फॉर्म बट नॉट इन द केस ऑफ नर्मदा. तो यहाँ पे irrespective of इंदिरा सागर प्रोजेक्ट or any upstream project, we will finalize the design of probable maximum flood of the downstream project considering as if those dams are not existing there.
Thank you, sir. Sir, next question is, what is the head for selection of design flood?
What is the
head for selection of design flood?
selection of design flood? So that you have to go for the as per BIS criteria. जो हमारे BIS code है that I have already shown in my presentation.
Thank you, sir. Any more questions, please? Any more questions? Okay, if there is no question, then our I will convey my sincere thanks on behalf of National Water Academy, CWC Pune. I'm conveying my sincere thanks to all officers who have joined this webinar series.
I think there is some question probably. Some lady officer is asking you a question. Yeah, please go ahead.
Sir,
Yes, madam,
this
please
is
ask.
SDSO Telangana, sir. Sir,
Yeah, please,
Sir,
please.
we require a step-by-step procedure for calculating the design flood review, sir. We want one session, sir, in detail, sir.
For we are conducting, Central Water Commission have conducted a number of courses in all the participating states, and in that complete lecture note. But again, if you want, you can request, and National Water Academy is conducting such type of courses. So NWA may conduct, if it wants, we can conduct a course, but that will be not one day. At least for that, at least 2 or 3 days are required to be very frank.
Yes, sir. Yes, sir. We are ready to take this that session, sir. So to go to the Pune, only 3 to 4 members are readily available, sir. So at this station only, we can learn so many members, sir. Through the video class.
Okay, no problem. So you can write to Chief Engineer NWA, and they will certainly see the schedule, and then the course can be designed for there also.
Okay. Madam, if there is a specific requirement of your state
Yes.
to train, say maybe 15 or 20 officers at your place in your state, we can organize that also. So please write to us. We will work it out and we will give you a slot.
Okay, sir.
But at least 15 to 20 officers are required
Yes.
to have a complete batch.
Yes, sir. Yes, sir. Yeah.
Okay. Thank
So
you.
you are calling from you are from which state?
Telangana, sir. Telangana.
Telangana. Acha, okay. Okay.
All right. Sir, next question is, if storage capacity at MWL is double or more than FRL, then can we consider it as flood cushion, that is reservoir routing for design flood in downstream side?
No, it can be considered, it cannot be. Here the complete information is not there. देखिए, there are two things. One, MWL has been provided as a flood cushion. In another case, suppose my spillway clear length was required 300 meter, but in Valley only 200 meter was available. So design flood had been routed and design flood is now passing at MWL. If that is the case, then no reservoir routing shall be required. If MWL is corresponding to dedicated flood cushion, then reservoir routing shall be required. So depending
Thank you,
upon
sir.
that.
Sir, next question is, what if PMP value is less than present observed rain? Observed rainfall होगा ये.
Present observed rainfall PMP value
Yes,
is less.
can anybody repeat the question who has asked? Mr. Arun, what is your question? Yeah, Mr. Arun is there.
Hello, sir. Yes, sir.
Yeah, kindly
Sir,
ask your question, please.
sir, drain is more than that previous PMP value, sir.
Then in that case, revision of the PMP value is essential. If the observed and actually more than that, it means whatever the earlier PMP was estimated, the rainfall value has exceeded that. Then the revision, this is the case of revision of PMP.
Okay, sir.
Yeah.
Sir, next question is, for storm of 13 hours to get synthetic unit hydrograph, do we use 1 hour after clock correction factor of 1.15 or do we go for same base length of time hour 13 hours?
No, if it is up only 13 hours, then no clock hour correction is required.
Okay.
Because that
Okay,
clock
thank
hour
you.
correction is required for 1 day rainfall, not in 13 hour or 12 hour or 8 hour rainfall.
Okay, thank you, sir. Thank
Sir,
you.
one more
Yes,
request,
any
sir.
more question, please?
Yeah.
Or we
Sir,
close the session?
sir,
Any questions?
for calculation of that detailed flood routing, sir, webinar session will be good, sir. We will be different if people can't attend at NWA, sir.
Okay, we can think for that also.
Okay, thank you. There is one announcement. Our next session on this webinar series on dam safety aspect will be on 3rd December 2024 on Tuesday, and the topic is reservoir operation and rule curve. To share his experience on this very important topic, Shri Rishi Srivastava, former Chief Engineer, Central Water Commission, will be the speaker to speak on this topic and share his experience on the reservoir operation and rule curves. Now we will close this session. On behalf of National Water Academy CWC Pune, I am conveying my sincere thanks to all officers joined in this webinar series across the country. I also thanks to our Chief Engineer of National Water Academy, Shri D.H. Chaskar sir, for providing his sincere guidance to conducting this webinar series. I also thanks to our today's eminent speaker, Shri N.N. Rai sir, for sharing his experience on this topic. I also thanks once again to everyone, and we will meet on next session on 3rd December 2024. Thank you. Namaskar.
Thank you, Milind.
Thank you, sir. Thank you. Now we will close the session, please.